This lesson covers quadratic functions in general form and their graphs. The general form for the equation of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. The graph of the quadratic function f of x is a parabola with vertex at the point negative b over 2a, f of negative b over 2a. The axis of symmetry is x equals negative b over 2a. Let's graph the quadratic function f of x equals negative 2x squared minus 12x minus 16. And we'll start here by finding the vertex and the axis of symmetry. To find the vertex, I will start by finding the x-coordinate of negative b over 2a. For this function, a is equal to negative 2, b is equal to negative 12. Negative b over 2a is equal to the negative of negative 12 over 2 times negative 2. This simplifies to negative 3. So my vertex has an x-coordinate of negative 3. To find the y-coordinate, I'll find f of negative b over 2a. Here, that will be f of negative 3. Plugging negative 3 into my function, I have negative 2 times negative 3 squared minus 12 times negative 3 minus 16. This is equal to negative 18 plus 36 minus 16, or this simplifies to be equal to 2. So my vertex is negative 3, 2. The axis of symmetry here is going to be the line x equals negative 3 that passes through the x-coordinate of the vertex. Let's find the x and y intercepts of the graph of this function. To find the x-intercepts, I set y equal to 0. So I have 0 equals negative 2x squared minus 12x minus 16. Simplifying a bit here by dividing through by negative 2 will give me 0 equals x squared plus 6x plus 8. I'll factor the right-hand side of this equation to get 0 equals x plus 4 times x plus 2. Setting each factor equal to 0 gives me the x-intercepts of negative 4, 0 and negative 2, 0. Okay, to find the y-intercept here, we will set x equal to 0. I'll have y equals negative 2 times 0 squared minus 12 times 0 minus 16. And my y-intercept here will be where y is equal to negative 16, the point 0, negative 16. Let's graph this function using what we've found so far. The vertex is negative 3, 2. The axis of symmetry is x equals negative 3. I'll draw the line x equals negative 3 with a dashed line here. X-intercepts of negative 4, 0 and negative 2, 0. The y-intercept of 0, negative 16, and I'll also draw the point that's symmetric about the axis of symmetry to this y-intercept. That would be the point negative 6, negative 16. And we'll connect these points that we found with a smooth curve. Giving us our graph of the parabola, like so. Okay, does the vertex here yield an absolute maximum or an absolute minimum? If you look at the graph, the vertex of negative 3, 2 is the highest point on the graph, giving us an absolute maximum. What is this absolute maximum? It will be the y value on the graph, which would be y equals 2. Let's check the vertex of negative 3, 2 by writing our function in standard form. Okay, so to write our function in standard form, I'm going to start by factoring a negative 2 out of the negative 2x squared minus 12x. So I'll have negative 2 times x squared plus 6x I do this so that there's a coefficient of 1 on the x squared here. And then the next step will be to complete the square for x squared plus 6x. Dividing 6 by 2 and squaring will give me, I need to add plus 9 here. What I'm actually adding though, I'm adding negative 2 times plus 9 to the right side of this equation. To counteract that, I will need to add 18. So I subtract 18, add 18, keeps the right side of the function equal to what it started with. And so f of x here is equal to negative 2 times x plus 3 squared plus 2. Remember, hk is my vertex when my function is in the form a times x plus h squared, a times x minus h squared plus k. So my vertex of hk here will be negative 3, 2. This matches what we found by using the general form of the equation of the function. Okay, let's try this last one on your own. Write the quadratic function g of x equals 2x squared minus 12x plus 19 in standard form.